Okay, guys, organic reactions would be the last part of our organic journey, and it is your question number 4. Okay, now when it comes to organic reactions, I'm quickly going to break this down into the different types of reactions that we should be expecting. Organic reactions. Now, let's look at it this way. The first thing I want us to see when it comes to organic reaction is the bromine test. Number 1. I'm going to look at 5 reactions. Bromine test. This is used to identify or let me use the word identify. Identify if a compound is saturated, if a compound is saturated or not. We're going to write as quickly as possible. This is used to identify if a compound is saturated or not. Now, bromine water is brown in color. All right, bromine water is brown in color. Unsaturated compound decolorizes bromine water. And that's the difference. Unsaturated compound, which are your what? Alkenes and alkynes, right? They decolorize bromine water. That is, if I have an unsaturated compound, and this I'm still going to look at, and I add bromine water. I'm using colors for now. This becomes a colorless liquid. But if I have saturated plus brown bromine water, it will remain a brown liquid. Unsaturated decolorizes bromine water. Let's write as quickly as possible. No time to waste. Unsaturated decolorizes bromine water. Now, let me quickly, I decided to look at this experimentally. Are you guys still writing? All right, I decided to look at this experimentally. Let me show you something here quickly. Oh my God, where is it? Oh no, I don't know where it is. There's a little experiment that I put to, oh gosh. Okay, I'll find it. I will find it. Just give me 1 second. Let me re-get it from the other laptop. I thought it was in that file. I played for you just now. And then we move to combustion reaction. Then we go to the main ones. strange. I thought I had it in there. Okay. You might not be able to hear the sound, but I will tell you what's going on. Okay, don't stress. I'll tell you what's going on. T for testing. Here we go. And you can just get it on YouTube. It's available. Okay, so here we have. Now here's the issue. I'll just post the video. Oh no, this guy is too fast. All right, this is what happens. We have two colorless liquids. We don't know which one is saturated and which one is what? Unsaturated. So we are going to drop bromine water. Bromine water is brown. Okay.
First, brown red bromine is added drop by drop to the left-hand tube containing saturated hydrocarbon. It disappears because bromine does not react.
Do you notice what's happening here on the left side?
The color remains.
Do you see it remains brown? That is what? Saturated. Okay, we're going to see that again and explain what's really going on here. But if I take the same bromine water, all right, we're going to pour the same bromine water in the second test tube. All right, the second test tube, you can see what's happening. It's decolorized immediately. All right, decolorized immediately. That is an unsaturated. Did that make sense? Were you guys able to see the difference between the two? Thumbs up, please let me know. I'm done there. That's an exam question. All right, number two. Combustion reaction. Combustion means something is burning. All right? It means a substance is burning that is reacting with oxygen, or let's say a reaction with oxygen. Now, alkanes, alkynes, even alcohols, all of them will react with oxygen, that is, they are burning, and they will produce carbon dioxide and water. This is what happens in a car. You know, your fuel burning and whatnot. All engines go through this. So alkanes, alkenes, alkynes, and alcohols all burn in, and this one we usually say excess oxygen to produce carbon dioxide. If it is not excess oxygen, they would have carbon monoxide. But for now, we are going to use excess oxygen, and that gives us carbon dioxide and water. And I'm done. Your job is to balance. And in most cases, they will give you alkanes. They normally use alkanes the most. I want to teach you quickly how to balance this particular one. Please don't go and use this in your other balancing reactions. Let's see if we can spend 2 minutes on balancing, or 5 maximum. Check this. This is what I do. If I have an alkane, oxygen, please look at what I'm going to do. I'm going to do 3 steps. Watch this, because some of us don't know how to balance, and balancing is 1 mark here. Please look at these steps. I'm not going to write notes down on this. Number 1, I am going to put a 2 in front of the C. Number 1, let's put 2 in front of C. Is that okay? Put a 2 in front of the C. Now, look at what I'm going to do. Do I even remember myself? I used to use this method. Put a 2 in front of the C. Are you ready? Now, I am done with that. Let me see something here. 2 times 4 would give me what? 8. Okay. Put a 2 in front of the C. Number 2. Remember when I have C, it's 1, right? Good. What is 2 times 1? I'm going to put my answer here. All right. So, 2 times the number of carbon. All right. And put your answer in front of CO2. Put your answer. I really don't like this note I'm giving. Put your answer. Once you get it, you're going to work very fast. In front of CO2. 2 times 1 is 2. Step 3. Multiply 2 by number of hydrogen. So 2 times 4 is what? 8. No, sorry. Take the 4. I'm forgetting my system. Let me see. 2 times 1 is 2. Carry the 4. Yes, this one we're not multiplying. Number of hydrogen. Transfer number of hydrogen. Sorry. Transfer number of hydrogen. We'll test it again. I've forgotten this thing. Transfer number of hydrogen to water. So if it's a 4 there, I put a 4 there. Okay. Now the last one, or second to the last one. Count number of oxygen and divide by 2. It's going to make a lot of sense, don't worry. Count the number of oxygen on the right and then divide by 2. Please check how I'm going to count. What is 2 times 2? 4. Plus this 4 here. That gives me what? 8. Divide that 8 by 2. What will that give me? 4. That 4 comes here. Don't worry, I know it looks sketchy, but we're going to get it. I'm only spending 5 minutes on this. And I'm going to balance like 10 quickly for you. This note is not necessary if you can just follow. But now, if you look at your compound, I know you are confused, don't worry. Do you see that they are all even numbers? We don't leave them like that. So I'm going to have to divide across by 2. Somebody says, but it's so much work. You will see just now that this is quite easy. And my dear learners, this is balanced. Don't worry. I know that writing the note and that you were a bit confused. I'm going to take you through again. All right. Everybody, look at this now. I'm doing another one for you quickly. I'm going to do one for you. Look at this. Let's do this together quickly without the note. C2H6 plus O2. Please follow. You're going to see how fast I'm going to do. What do I do? Start with A, 2. 2 times 2 would give me what? 4. I'm going to put that 4 there. What's my next number? I'm done with the 2. What's my next number? 6. Copy and paste. Now go to the right. 4 times 2, 8. Plus 6, 14. Divided by 2, 7. And I'm done. It's balanced. Okay, I'm going to do 3 more. I was lying by saying I'll do 10. It's a lie. Oh, this issue of 2 pens is going to make you write slow. Nana, write with 1 pen. Because I need to move to the next one. It's going to make you write so slow. C3H8 plus O2 to give us, remember, this one is always there. If I leave it like this, I have 1 mark on the right, 1 mark on the left. But let's balance. I need that last 1 mark. What do? Put a 2. 2 times 3, 6. Take the 8, copy and paste. 6 times 2, 12. 12 plus 8, 20. Divided by 2, 10. Please always check my numbers. It's 2, 10, 6, 8. No, I need to divide by what? By 2. So what do I have? C3H8 plus 5O2, 3CO2 plus 4 H2O. I don't know if this makes sense. Let's see. Do you think you got it? Do you think you got this? Otherwise, balance your own way. Let's do two more together. Two more together. I'm running, guys. I'm running. C4H what? C4H10. Let's try that quickly, everybody. C4H10. C4H10 plus O2 to give me what? CO2 plus H2O. What's my first step? Put a 2. Now you work with the 4. 2 times 4, 8. Move to the 10. You don't multiply now. You copy and paste. 8 times 2, 16 plus 10. 26 divided by 2, 13. And I'm done. Balanced. I don't need to divide by 2. Okay, I am doing the last one and then we'll move on. You try this. Balance this one for me quickly. C5H12 plus O2. Everybody, please balance this. You only have 15 seconds. Please stop copying and balance this one. 15 seconds to balance. 15. Normally we use the test I do is we use 7 seconds to balance it. 7 seconds. That's what we're going to go to. We're going to cut it short now. What? How many seconds did I give you? 15. Never. It's just for. Oh, I gave you 15 minutes. Never. I'm wondering. You have 10 seconds left. I'm wondering, Joe. Yes. Time up. Time up. What do I do? 2. 2 times 5. 10. Carry my 12. Put it there. 10 times 2, 12. 10 times 2 is 20. 20 plus 12 would give me what? 32. Divided by 2, 16. But check your numbers. They are all even numbers, right? So what do I do? Divide by 2. 5CO2 plus 6H2O. The last one for you to practice. Everybody. C61214 plus O2 to give you CO2. Please make sure you finish. You have 15 seconds. Don't worry, this time I'm not making that mistake. 15 seconds. Okay, let me stop. You are still writing the question. 1, 2, 3, 4, 5. 15 seconds. There we go. Balance that. Hey, you like calculators. That's why you didn't finish. Are we done, everybody? Were you able to balance it? All right, quickly, what do I do? 2. 2 times 6? 12. I put my 12 there. Transfer the 14. So what do I have? 12 times 2? 24 plus 14 will give me what? 38. Divided by 2, what do you have? 19. I'm done there. All right, reaction number 3. But if you didn't get it, please use your own method of balancing. And don't use this everywhere. It only works here. Okay. Now, reaction number 3 would be our main reactions. Guys, these are the main reactions that we are looking at now. There are 3 types of reaction. All right. 3 main types. three main types. Three main types. Please follow me. We are going to have what you call substitution reaction. We are going to have what you call addition reaction. And we are going to have what you call what? Elimination reaction. Substitution is to exchange. Addition is a plus. You are adding something. Elimination is to remove or delete. I am going to be needing that word delete. Substitution, exchange. Addition, you are adding. And what are the things that we are going to add? And what are the things that we can, before I look into all of them, what are the things we can add? What are the things that we can eliminate? Okay, so let's create a table quickly to say addition, and elimination. So for the elimination, I'm going to use DE. Number one, what can I add to a substance? I can add hydrogen. I can add what? Hydrogen. Hydrogen. And in adding hydrogen, it's going to be H2. And what is the name that will be called? I am adding, it's an addition of hydrogen. That is called hydrogenation. The nation, addition of hydrogen. Hydrogenation tells me I am adding hydrogen. And I can also remove it. If I remove it, I am using the word D from delete. What am I removing? Hydrogen. So we call it what? Dehydrogenation. I can add my halogens, which is my X, and you know them. Bromine, chlorine, iodine, fluorine. Halogenation. That's where it gets its name from. Halogenation. And if I'm removing, thank you, dehalogenation. I can add water. If I am adding water, it is called hydration. And if I'm removing water, I'm sure you've heard people say I'm dehydrated. They don't even know what they're saying. They're just using big words. Dehydration. You know, people just want to be scientists by all means. And they use big words. I'm dehydrated. Like, what are you saying? Why are you dehydrated? You know? But everybody wants to do organic chemistry. I can add hydrogen halide. What is a hydrogen halide? It's a hydrogen and one halogen. Hydrogen, remember your X is the halogen. So hydro from hydrogen, halide from halogen. Now that is called hydrohalogenation. And obviously, if I'm removing dehydrohalogenation. Let me know if the names make sense to you. You got those names? Addition, and the removal is called delete. So D, whatever you are removing. Okay, let's go to the real thing now. We're still playing. We are still playing. Now, what I need you to do for me, I'm going to quickly discuss my reactions and then discuss two important things, and you will see all of this come into play. Can I move the screen? I'm just waiting. I don't know if you guys are done. If you are not done, I need a thumbs down. But it seems like everyone is giving me a thumbs up. All right, you let me know. But so far, I'm seeing everybody giving me a thumbs up. Now, quickly, guys. Please, what I need you to do is this. Identify saturated and unsaturated compounds. Saturated and unsaturated compounds. And for me to get saturated, what am I looking for? Single bonds. And for unsaturated, what am I looking for? Double or triple bonds, right? And please, I am not saying hydrocarbons. I am saying compounds. So examples of saturated compounds would be what? Your alkane, your haloalkane, and your alcohols. For double or triple, where do we see those that we're going to need? Your alkene, your alkyne, and the one that we are going to need again would be your esters. But I would not want to put it there. Let's just remove it. I don't want to put it there. Okay. Taking you gradually. Once you know how to identify, we're good. My good learners, I used to tell a story here. A quick story just to create an acronym for you. That's what I do to teach this. To say that before I got married, I was single and I was seriously searching. I was single and I was seriously searching. I was on what? I almost wanted to say I was on Temu. Oh my God. How can I go and search on Temu? In fact, I want to buy a small dolly. Okay. But I was on, honestly, it was Temu that came to my mind. I was searching on all social networks, searching for someone. Then, it's a quick story. Then a friend of mine said, no, dude, I need you to travel and go to the United States of America. So I went there, USA. And I found a girl, her name is Susan, but I don't call her Susan. I call her Sue Baby. So she's my Sue Baby. And I wanted to see what I just told you. This acronym alone just tells you what to do and automatically tells you the type of reaction. The first S tells me, in fact, S here is, once I see S, if I am moving from a saturated compound, if my reactant is a saturated and my product is a saturated, it is a substitution reaction, which means I am only exchanging. What is my U? Unsaturated. So if my reactant is unsaturated and my product is saturated, it is simply an addition reaction. And that's all I'm checking in any paper. And if I am starting from a saturated and my product, that is, I am moving to unsaturated, I automatically know it's what? An elimination, and that is all you are searching for. Question is, will you be able to identify something saturated and something unsaturated? That's all. Already that gives me my type of reactions. Let's just put a little heading here to say reactant, product, and reaction. If I am moving from saturated to saturated, and that's what the flow diagram would be like. Saturated to saturated is a substitution, SSS, then USA, and I'll show you how to apply this. We've got some time. Beautiful. I love it. I love it. We are almost done, guys, and we're going to use this. Now, very important is my reaction conditions. Reaction conditions. Please, this is important. Reaction conditions. So if I were to continue my story, I'll say, okay, Bishop weds Sue, right? Just to make it nice so you remember. Bishop weds Sue. But for me to get married to Sue, there must be a lot of chemistry going on in between us, right? So instead of saying weds, I'll use the word seds. C for chemistry. And these 4 letters explains my reaction conditions. C. When I use concentrated, or anytime I see concentrated strong base, example, my strong base, sodium hydroxide, potassium hydroxide, the type of reaction that I'm doing is an elimination. So every time I am eliminating, there must be concentrated strong base. Let me add something to that. Plus strong heat. Eliminate means I want to remove. So I need to come in very strong. If I want to remove you from your chair now, I won't say, oh, come on, please move away from my chair. No, nobody's going to move. Now you're sitting on my chair. Please kindly move away from my... No. I need to come in strong. Hey, move. So concentrated, I'm coming in strong there. Plus strong heat. That is elimination. Now, what does the D stand for? What's the opposite of concentration? Dilute. So dilute. Strong base again. Every time I see dilute strong base, again my strong base, sodium hydroxide, potassium hydroxide. What type of reaction am I doing there? It's a substitution reaction. And since I am substituting, I'm kind of playing here. I'll be using mild what? Heat. And those are my conditions. So every time I am, so your first job is to check, am I substituting? Am I eliminating? By looking for whether it's saturated or unsaturated. Then I look at my reaction conditions. If it is elimination, it has to be concentrated base and strong heat. Or if it is substitution, then I say dilute strong base. I'll show you these things practically as we answer questions shortly. Are we okay, everybody? Are we okay? Is this thing making sense to you? Somebody saying, but don't worry. Okay. Reactions and catalysts now. Reactions and catalysts. Reactions and catalysts needed. I think I have about 6 that you need to know. Oh, I mustn't forget. I need to look at cracking. Reactions and catalysts. Let's do a table. A reaction and the catalyst needed. Reactions and the catalyst. Hydrogenation. Remember, what are we adding here? Hydrogen. We use platinum, which is PT, or nickel, which is Ni. Hydrogenation. This is actually this is used in margarine. You see your margarine that you have? Yeah, it's called hydrogenation. Hardened oil. We use platinum. Halogenation. The addition of halogen. We are using ultraviolet light. Or you will see some will just say sunlight. Because your sunlight is UV, if you remember grade 10, when we're doing electromagnetic radiation. Yes, talk to me. Now, lady. Hello, Nana.
Is it okay if, like, for halogenation, if you use heat only?
For what?
For halogenation, is it okay if you say the catalyst is heat?
No, it's not. Because if you say heat, then I could say it's strong heat. I'm not sure. Or mild heat. Do you understand that?
Yes, sir.
So we want you to be specific. There's an amount of heat that we need for that reaction. So if you say heat, that's why even in the ones I did, you see I didn't say heat. I was specific. Strong heat and mild. It makes a lot of difference.
Okay, thank you, sir.
You are most welcome. Number 3, hydration. Remember, we are adding water now, right? But I want to say hydration of alkenes to alcohols. So we can add water to an and it makes sense. My alkene is unsaturated. My alcohol is please check. Alkene, it's a U. Alcohol, S. What is the last letter? A. U-S-A. And that is addition what? Reaction. And if you check, hydration falls under what? Addition. All right. What is my catalyst? We use dilute sulfuric acid. I'm just going to write dilute SH2SO4. Or excess water. This actually, I shouldn't say oh, let's just put an addition there. Dilute sulfuric acid or phosphoric acid and excess water. Let me write the names of these acids because some of us might not know what they mean. This is sulfuric acid. Some of you use F. I think the new name is F. sulfuric acid and phosphoric acid. Plus what? Excess water. Where is the water coming from? Remember, we are saying what? Hydration. We are adding water. Excess water. We have just two more. Hydrohalogenation. This one, there must be no water. That's the condition. If water is present, it's going to go into alcohol. No water. No water. And finally, esterification, which is what most of you did as your experiment. Esterification, which is an elimination. This is actually dehydration, because we are removing water. And if you want to remove, what do we need? We need a concentrated sulfuric acid here, plus strong heat. And my strong heat here is using a water bath. You guys did this in class. Can somebody tell me why we use a water bath? And what is a water bath? Why do we use a water bath? Let me see. Who's that? Yes, Naledi?
So I think it's because during the reaction with alcohol involved, and alcohol is highly flammable. So therefore it's like a safety precaution that is used.
Wena, you are a bomb. You are a chemistry bomb. We use a water bath, and she's correct. Why? Alcohols are flammable. All right, you guys know I set up my practical illusions here. Water bath. Unfortunately, I cannot change this one. I won't change my background. We're going to use it like that. No, why? Please write that reason in case you didn't know. Using a water bath. I just want to explain what that water bath is. All right, so I have my lamp there. Okay. So we use a water bath. We boil the water, and our mixture of that is there. We use a water bath. So we don't put the test tube directly on fire. We boil water and put the, like if we are doing food for baby. You know how we used to, when you're a baby, when you're crying, we put the thing in the water bottle in that. Okay. So that the reaction doesn't catch fire. Okay, we don't answer like that. We answer chemistry-wise. Use a water because alcohol is highly flammable. Okay, to catch fire is a street language. All right, guys, this is the list of catalysts that you need to know. Rewrite these, make sure you know them, and you are good. Quickly, because I want us to answer questions now, and we'll be coming back to the notes, to fetch notes. Can I quickly deal with Markovnikov's rule and Zaitsev? Very simple. No one is going to ask you to state it, and I'm going to apply them shortly. Okay. During addition and elimination reactions, we apply Markovnikov. That's my uncle. Markovnikov. It's a Russian. Markovnikov and Zaitev rule. No one is going to ask you to state, please. Don't start Googling and asking AI. Don't disturb AI. AI needs to rest. Don't go and be asking AI to define Markovnikov's rule. This guy disturb AI too much. Let them also rest. Okay. All we need to do is to learn how it works. During addition, the carbon atom with more hydrogens get the hydrogen atom to be added. In an unsymmetrical compound. Unsymmetrical means you cannot really divide it by into two, right? And quick, we are saying the rich gets richer. So the one that has more hydrogen will get the hydrogen. I'll look at an example with you, don't worry. I'm almost done. By 6 to 6:30, I want to look at questions. During elimination, the carbon atom with the least carbon, with the least hydrogen, loses its hydrogen. The poor gets poorer. We punish him for being poor. He's already poor, we punish him the more. That is what the capitalist system does. For the one that is rich, they get richer, and that's what's happening in life, right? So even organic compounds know life. The rich gets richer, the poor gets poorer. That's how it is. It is what it is, my people. Okay, anyway, I want to quickly finish how we can apply all of this so that we can apply. So we apply at Markovnikov's when we are at. Let me see if I can create one quickly for you. Let's try to create one. If I have that, beautiful. This one would work. It's unsymmetrical. Just to show you. Plus, let's add HBr. What are we going to get? I want you to look at this. So I have 3 carbons. Remember, this is what? Unsaturated. I know definitely I am only going to a saturated compound. So my 3 carbons will still be there. All right, these ones have that. This is what we have, guys, originally. I'm going to use a different ink to show what's going to happen. And this is carbon 1, carbon 2, carbon 3. 1, 2, 3. Our double bond will be separated. Please hold on. I know you want to write. Just hold on. So our double bond is in between carbon 1 and 2. So I'm going to separate it into saturated. There we go. But now I've got 2 things to add. So we are going to look at those carbon atoms. Which one is the rich one? Is it carbon 1 or carbon 2? Can I get answers from you? Which one has more hydrogen? Which one is richer? 1 or 2? Carbon 1. Carbon 1 has 2 hydrogens, while carbon 2 has what? 1 hydrogen. They know how to do business. The rich get to. So this guy knows how to do business. We are going to add this hydrogen to this guy. And then this becomes what? Br. Please, did that make sense? And this is called the major. Oh yeah, we just put a note here. This forms the major product. All right, this forms you would always see major product. This one, if you follow the rule, it forms the major product. All right, going otherwise, forms what you call the unstable minor product. That is, if I were to switch the laws, I'm going to form something that is called a minor product, and it is unstable, so it doesn't stay for long. It forms an unstable minor product, and that is our Markovnikov's rule. I want to do the Zaitsev now. Elimination. Just give me a thumbs up if you are okay with how I added the H and the BR. The rich gets richer. Let's look at an example of the Zaitsev when we are removing. Can I move? Okay. All right. Zaitsev. Let's look at how do we remove stuff. I had 3 carbon atoms there, right? That one is not going to work. Let's use 4. 1, 2, 3, 4. Okay, I have a BR here. Because I am removing, do you notice it's what? Saturated. You don't remove from something that is unsaturated. You can only remove from saturated. Now I want to remove. Okay? And good learners, please check. Because I want to eliminate, what is my reaction condition? I need to use concentrated what? Strong base. So the examiner will tell us NaOH. But they cannot just leave it as NaOH. They must tell you concentrated. Because if they tell you NaOH, then the question is vague. You cannot answer such questions. If they tell you NaOH, read carefully. They are going to lead you. They will ask you whether it's concentrated or not. Now I want to, since I see concentrated, remember, I must also have what? What type of heat? Strong heat. But I want us to remove. That's the main thing that I want us to remove. I want us to remove. First, I'll come with my carbon. Okay, please look up, everybody. Stop writing for a moment. Stop writing for a moment, please. You rather understand and then write later. Please check. I am definitely going to remove a BR. Okay, let's call this carbon 1, carbon 2, carbon 3, and carbon number 4. So from my carbon 2, do you notice I have removed the BR? Okay. But I cannot just remove the BR because I want to have a double bond now. One hydrogen must go. I am now going to look at the hydrogens that are next. It's either 3 or the carbons that are next, or 4 or 1. Please understand. I removed the bromine atom from carbon 2. Don't go and remove the hydrogen from carbon 2 again. That is wickedness. The guy has already lost the bromine atom. So I'm going to check the ones that are by the side, either carbon 1 or 3. Okay, let's do business. Since I am removing, the guy is going to become poor. Who do we punish? Carbon? Why carbon 1? Read the notes. I put a little thing in the bracket. The poor gets poorer. Carbon 1 has 3 hydrogen. Carbon 3 has 2. Who is poor? Carbon 3 is poor. We punish him for being poor. So we remove 1 hydrogen there. Please, does that make sense? We punish him. When others were working, you were sleeping. When they were making money, now you were watching Liverpool and Chelsea. Now you are going to suffer. That's the whole life story. Yeah. Guys are laughing. We punish the poor guy. Others are waking up to work. He is chewing gum. A full adult at 10 o'clock. Chewing gum. Wearing pajamas. We punish him now when we go to Woolworths. You can't buy cake. So, what will it be? Now, do you notice I have a problem with my bonds? There needs to be a double bond somewhere because carbon must be 4. I need to come back and put, because I removed, do you notice I have now removed, I'm using the green one to represent the one I have removed. I removed on carbon 2 and carbon 3, so my double bond should go between carbon 2 and guys, we are done. Check what I have. Everything is done now. And this is called the Zaitsev rule. The rich gets richer and the poor gets poorer. Did it make sense to you all? Rich gets richer, the poor gets poorer. Even these things understand life. Finally, cracking. Cracking. If you take something and it cracks, what happens? It becomes smaller. That's what comes to my head. If I take a biscuit and I crack it, break it into 2, I'm going to have small pieces. Cracking. Small pieces. The chemical process in which longer chain hydrocarbon, please, it must be a hydrocarbon, and I hope you remember what your hydrocarbon is. Compounds that contain carbon and hydrogen atoms only. Hydrocarbon molecules are broken, that's the word cracking, into shorter, more useful molecules. Look at those words. Shorter, so the chain becomes shorter, and they are more useful. And there are 2 types of cracking. Two types of cracking. 1, thermal cracking. This is where we use high heat, therm from the word thermometer, and high pressure. And number 2, catalytic cracking. This is where we use a catalyst to crack. Forms of cracking, or don't let me use the word forms. Cracking reaction types. Let's use that. Cracking reaction types. There are 2 types as well. 1, I can have an alkane, and that alkane would break down. It can break down into two types. So the examiner would show you what you have. It can break down into an alkane plus an alkene, and secondly, it can break down into alkene plus alkene plus hydrogen. Alkene plus alkene plus hydrogen. And if I tell you that I am done with organic reactions, what would you say? I can just quickly look at esterification again. Let me know once you are done writing. Alkene, alkene, H2. Huh? Yeah. I'll show you an example. Let me show you an example to explain that. Let's look at an example quickly. Cracking reaction types. Can I move to the next page? Just quickly show an example of this one. And then we take a full question now and just play with it, and just have fun. Okay, look at this. If I have C10, H22. Okay. C10, H22. I possibly could have two types of reaction. Let's get an alkane. If I am using an alkane, for example, C4, H, what? If it's an alkane, I want an alkane here. Use the formula, 4 times 2, 8, plus 2, 10. What will this be? The next one. Guys, all you are doing is you are counting. That's all. I have 10 carbons, but I've used 4. How many carbons do I have left? 6. I have 22 hydrogens. I have used 10. 12. And you will notice that's an alkane, because it's CN, H2N. This one is what? CN, H2N plus 2. We're done. We just add. That's all. I could have the same C10, H12, H22 break down into an alkene. C5, H10. Or let me say let's go for C4, H8. That's an alkene because it's double. All right? It's an alkene here. Watch this. How many carbon atoms do I have left? 6. Let us form another alkene. Double it. 12. Is that fine? Every time I double, alkene is double bond, so I double the number. Is it balanced? I have 4 plus 6, carbon 10. 8 plus 12, 20. Hydrogens, right? What am I short of? Huh? 2 what? Good. And that's why I wrote that there. Alkene, alkene plus hydrogen. I don't know if it makes sense. Guys, are you okay? Did it make sense? right, my good learners, let's get 2 questions. I think we have enough time. We'll have enough time for 2 questions and see how to use everything I have taught you. I was working with some papers today, doing some other topic. Let's see if we can get from there. Okay, let's see this one. Let's see. Whatever we find, we do, guys. We are not shying away. Beautiful. Yummy. Yummy, 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 yummy. Yummy, yummy, yummy. The flow diagram. I love it. 15 marks. 15 marks. Please read. Let's read together. The flow diagram below shows how prop 1 in can be used to prepare. I said I was going to look at esterification. Can I answer this quickly? All right. Prop 1 in. Now, they said prop 1 in is used to prepare. So this is where our source is. My good learners, check what I'm going to do. I am looking at this. And I see propane. Okay, prop 1 in is unsaturated, right? Beautiful. Guys, remember, look at this. SSS, SUE, and USA. The only place I have this is there. It's unsaturated to what? It means all of these other compounds are what? Saturated. I can already tell you. Can you see it's alcohol? Beautiful. This one will also be what? Because from U, I can only go to S. Does that make sense? Does that make sense? Let's walk through together. From U, look at my acronym. From U, I can only move to S. I cannot move to U again. So already by saying, are you aware that already this is what? Addition reaction. This is also what? Addition reaction. This is also what? Addition reaction. Already. Wait, I'm putting it in the wrong place. I'm putting it in the wrong place. My addition reaction is here because it's going to the left, right? Can you see? C is correct. C is going to the right. Okay, I hope you see the arrows. Addition. It means going back is what? Elimination. That's the opposite. Elimination. Does that make sense, guys? From saturated to unsaturated, elimination. Saturated to saturated, addition. Check. Look at how I'm busy playing. I just play when it comes to this topic. Write down the type of reaction represented by A. It's an addition. Now, what am I adding? Guys, if you want to enjoy this, oh my God, just think of the structures. Look at prop 1 in is what? That. Prop 1, it means my double bond is on carbon number 1. No, don't make such mistakes. Prop 1 in. We are going to A. Look at A. What is A? Propane. If you can just quickly draw your structures. Guys, by looking at these 2 structures, what are we adding? What do you notice? Do your stock taking. C3, 1, 2, 3, 4, 5, 6, H6. What is this? C3, what do you notice? From C3, H6, what do you do to get to C3, H8? Add 2 what? You need to be specific. All right, we add what? 2 hydrogens. Thank you, we are done there. So it's an addition, but what type of addition reaction? What are we adding? So what's the name? Good. You can either write addition, it will be marked correct, or hydrogenation. My good learners, are you with me? And what is the catalyst for hydrogenation? Anybody remember? Now you go to your catalyst note. Hydrogenation is nickel or platinum. I'm just going to put it there, platinum or nickel, since we are revising. Catalyst, done. Look at the next one. What is D? Okay, let's finish before you take pictures. Guys, let's look at D. We've already answered. Do you notice D is from what? Saturated. You know what I should... Oh, it's fine. Saturated to what? Unsaturated. What is that? Elimination. Okay, wait. I don't know if I do this. Sorry, 1 second. Let me do something. For complete clarity. Okay, co-pilot, you can't help me. Move away. Okay, let's work on this quickly. We started from Prop 1 in, right? Going to A, we said A is what? Addition. And what are we adding? Hydrogen. So hydrogenation. Let's look at B. Let's look at, which one were they asking for? D. Okay, look at D. Do you notice we said this is what? Unsaturated, right? Automatically this has to be what? Is saturated. And that's why HBr is being added. What is this? This is what? An addition reaction. And what is the name? Hydrohalogenation. What is the condition? No water, if you remember. There must be no water. Otherwise it becomes an alcohol. Okay. What do you think D would be? We are now moving from saturated back to unsaturated. What is this? Elimination. And what are we removing? Remove what you added. Dehydrohalogenation. And since it is elimination, what do we use? Concentrated sodium hydroxide. Everything I spoke about, I'm just throwing it in now. Let's go to B and C. C is going to the right. Unsaturated. Alcohol is what? Saturated. Oh. This is an addition reaction. And this is hydration. Go and check the reaction and catalyst I gave you. It's right there. I think it's number 4. Number 4, I think. Is it number 4? I don't remember. It says hydration of alkenes to alcohols. Number 3, hydration of alkenes to alcohols. And what do we need? Dilute sulfuric acid and excess water. It's called water. Excess water. Okay. So if you know my notes, you just be adding it. So what do we have here? Dilute H2SO4 or H3PO4 and what? Excess water. What about B? We're going back. Elimination. Since we added water, we are doing the opposite. What will it be? Dehydration. Okay, let's look at E and F. Do you notice E? We are moving from a saturated to another what? saturated. What is that? SSS. Substitution what? Reaction. Even dark, F is also what? Substitution reaction. Please, guys, I don't know if I have made sense with all of this. Have I made sense with all of this? I don't know if I'm just putting this, just wrapping it up in your hands. Here is what I'm going to tell you quickly. What is the difference between hydration and hydrolysis? What is the difference between hydration and hydrolysis? Let me add this on the note I gave you where we were having reactions. Where was it? Just go back a little and add hydration and hydrolysis. Ooh, there's no space. Okay, just add it anywhere, but make it very conspicuous. When it comes to water reactions, when it comes to water reaction, H2O reaction, there are two types. It's either we have hydrolysis or we have hydration. If it is hydrolysis, it is substitution. If it is hydration, it is addition. Hydrolysis is substitution. This, you know how I remember? I'll tell you how I remember. Something silly. Look at what I do. I read it. Hydrolysis is substitution. The IS, the last IS, is substitution. And hydration is addition. Okay, let's answer this because I want to just wrap up. Let's look at those questions and see if we have answered all the things that the examiner required from us on that question. And then I can just wrap up on esterification. Let's go back and look at the questions now. I want to see if we've answered. What is F? We said substitution. We answered all of that, right? F is substitution. Okay. Now, write down the name or formula of the catalyst used for reaction A. I think we did mention. We answered reaction A. It's hydrogenation, right? So what's the catalyst? Platinum. Platinum or nickel. I don't know. We wrote it down somewhere now. Where did I write it? Oh, there. It's there. It was answered before it was answered. Name or formula of the inorganic reactant needed for B. What is B? Let's go to the big page. B is what? Elimination. All right? And if you are eliminating, what do you use? It's there. CEDS. Elimination. No. Huh? Look at your reaction conditions. It's right there. CEDS. When you eliminate, what do you do? You wrote it down. It's right there. When you are eliminating, what do you do? Concentrated strong base. You don't understand the note you wrote. CEDS, concentrated strong base, you eliminate. Dilute strong base, you substitute. All right, guys, that is done as well. Elimination. I'm just pointing you back to your notes. All right, or you can, good, Michelle, you can also use concentrated sulfuric acid. I'm just pointing you back to the notes because I don't have time to write. The type of addition reaction at C, I think we did. We mentioned the type, hydration. Now, guys, anytime, look, I want you to see the difference between, please look at the difference between question 4.1 and 4.2.3. When the examiner says type of reaction, you can either write it generic or you can be specific. Both are marked. But here, the type of addition, you cannot write addition anymore. We're already telling you it's addition. And if you look at my theory and my stories, do you notice we got it right? What is C? It's an addition reaction. But what type of addition? Hydration. Are we okay, everybody? Last one, IUPAC name of X. Let's see, where's X? IUPAC name. The name. Okay, I want us to do that together. IUPAC name of X. Where are we starting from? From prop 1in. And we are adding what? HBr. Wait, guys, this is, I'm a prophet now. Do you notice that this was the same example I used? Was it this one? Yeah, this was the same example. Look, that's it. Same example. What is that? What is the name of this compound? Prop 1in. And we're adding what? HBr. Can you tell me the name of this compound? This is our compound X. It was the same example. Somebody quickly tell me compound X. What is the name? I'm waiting for you one day. What is the name of compound X? Prop 2in. How can that be prop 2in? In means alkene. What is this? Single bonds. It cannot be in. Talk to me quickly. What is the name of this compound? Huh? 2-propane. Wrong. What is this? Yeah, where is it sitting? So what's the name? 2-bromopropane. You cannot not know how to name that. 2-bromopropane. And that's the same thing the examiner was asking us there. So we are done with that question. I want to finish because I promised. Now, use structural formula to write down the balanced equation for B. May I please ask you to do that for me? First is to understand what what that alcohol is. So please start from prop 1in and form an alcohol. Let's do that first. Prop 1in, we need to form an alcohol. Prop 1in. Prop 1, we need to form an alcohol. We are starting from here. And to form an alcohol, what are we doing? We are adding what? Water. And your water will break down into, oh, this is wrong. Structural. If I'm using structure, guys, I have to do this. So I want to form the alcohol. What are we going to get? There's something I need to tell you once I'm done with this. Again, I'm using what? Markovnikov's. We are just repeating that. And one day, which one receives the hydrogen? Carbon 1 or 2? Carbon 2. Why carbon 2? But we are adding. Read your Markovnikov's rule. When adding, the rich gets richer. Which one is richer? Carbon number 1. And then we have our OH on carbon number 2. Don't get it mixed up. Guys, are we okay there? And what is the name of this compound? Propan 2 what? Or. But if I'm reversing, what are we going to have? Let's reverse it. Let's reverse it. In reversing, what are we doing? We are removing water molecules. So what do? The first thing is to remove my hydroxyl. That's what's said. So I already know that that one is no longer there. The question is, which hydrogen will I remove? In this case, we can remove any. Why? This is symmetrical. On the left-hand side, that carbon has 3. On the right-hand side, the carbon, they are both the same, so we can remove from anyone. So it doesn't matter. Get rid of that. So what do we have? H, 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 H. But there's a problem. I am removing from 1 and 2 and 3 here, so plus, since I removed water, and I can use concentrated sulfuric acid to remove. Please, did that make sense? I don't know if it makes sense, people. It's so simple. Markovnikov, Zaitsev, rich gets richer, poor gets poorer. You remove from the one that is suffering. You suffer the guy. You know what you are removing. You write what you are removing at the end. Blah, blah. We are done already. Now, lady. Hunjalunje. I don't know if it made sense, guys, if the whole lesson made sense to you. Yes, Michelle?
Okay, I'm confused. You see, for 4.2.2. 4.2.2.
Sorry, let me just go back to that question. Yes.
Yes. Would you say concentrated H2SO4 or concentrated strong base?
Okay, since it's no, we can use anyone. Anytime you see concentrated, we are removing. So I could also use concentrated sodium hydroxide.
Oh, okay.
But for this particular case, I'll prefer you to use concentrated sulfuric acid. Why? It is a dehydrating agent. Is that okay? It has a dehydrating ability, so it helps to remove water. Are we okay, everybody? All right. Let's answer now this one. Okay, let's look at the last one. Both reaction D and E take place in the presence of strong. Please, this is beautiful. both reaction D and E. What do you notice about reaction D? What did we say reaction D is? Elimination, right? What about reaction E? Substitution. And both of them occur in the presence of what? Strong base. But state two conditions that will favor D over E. The answer is right in your notes. If it is elimination, what are the conditions? Already I know it's strong base, but this has to be what? Concentrated, strong what? Base, that is 1, plus strong what? Heat. I'm done. If it was substitution, what is it? Dilute, strong base, plus what? And guys, in closing, I quickly want to draw this reaction, please. I quickly want to draw this reaction. Did that make sense, guys? Do you see the difference between the two? I want to draw these two reactions side by side, and then we can shut down. But I'm hoping that I have been able to assist you with organic reactions. Use this, and you'll be good. I want to move from what? Compound X. What is our compound X again? 2-bromopropane. Okay, guys, are we still writing? Because I want to draw both D and E. I want to draw both D and E to see the difference between the two. Can I quickly draw that? Can I move? Thumbs up, thumbs down. Let's see. Compound X, 2-bromopropane. And let's see where it's going to lead us. All right, please. The examiners like this particular trick. All right. I will draw both of them on the same page. One on top and one at the bottom. 2-bromopropane. 1, 2, 3. I have my bromine there. Hydrogen, 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 hydrogen. Okay, you can just take a screenshot of this when I'm done, guys. I want you to listen carefully to this. Br. So we have the same thing. We are going to add concentrated sodium hydroxide. Here I am going to add dilute sodium hydroxide. Here I will use strong heat, and here I will use what? Mild heat. Okay, back to reaction 1. Because it is concentrated, it's going to be what? Elimination. What are we removing? We are going to remove that BH. In this case, we can remove any of the hydrogens. They are both having the same number. Okay, so what would I have? 1, 2, 3. I have that, right? So what do I need? I have removed between carbon 1 and 2. I must have a double bond. But, my beautiful learners, please check. I am now removing HBr. This is an acid. Grade 11. This one here is a base. When a base reacts with an acid, what do we form? Salt and water. Now, the way you're looking at me is like you've never heard salt and acid and base before. NaBr plus H2O. Please take note there. This is a salt and this is a water molecule. Why? Because I have acid and base. Please, does that make sense? When an acid, grade 11, in fact grade 10, acid reacts with a base to form salt and water. But look at the second reaction quickly. I told you just going to take a picture of this. What am I doing here? This one is eliminate. This one is what? And what does the word substitution mean? Exchange. So here, if I want to do it for you very well, I'll write NaOH. Look at what we're going to do. We are going to take this OH and replace that. So what are we going to form? 3 carbon atoms. It is still saturated, but what do I have now? OH. Oh, do you notice we form an alcohol here? Plus what? NaBr. Please look at the two reactions and tell me if you are okay. Substitution, we exchange. Elimination, we remove. We have an acid and a base, which will give us salt and water. Ekfrustan? Nay or yay? My Afrikaans is on point. Nay or yay? Yeah. I speak better Afrikaans than... Naledi, I speak better Afrikaans than you. You know that, right? My Afrikaans is better than yours. Hamani, are you okay, Nana? Fatima, are we good? Simeka, Rati, Lindo, Karabo, Zwalu, Isa, Zahim. Does this make sense? Venusha, is this making sense to you all? Teboho, Lindela. So guys, use what I did, get the notes, and you're good. Let me just quickly write one note on esterification. Already you did that at school, but for the sake of me touching it as well. Esterification, and we did the naming. Right? An alcohol plus carboxylic acid will give us what? Ester plus water. And what are our conditions? Concentrated sulfuric acid plus what? Strong heat. Okay, two important things. We use a base, most of the time sodium bicarbonate, to isolate the ester by neutralizing the acid present. So when you take a base, you neutralize the acid. Number two, we add water to the mixture to be able to separate the oily ester from water. Esters are oily. Number 3 point that I need you to know. Large molecule esters don't smell as much as small molecular sized esters as they are dense, have high boiling points and less volatile. I am done for the day. Organic reactions done and dusted. All we need now is questions, which you can practice and apply what I did. If you just apply what I did, know the conditions, know the reactions, you will be good. Let me know if everything is okay. Volatile means it can change quickly from a liquid to a gas. Like if something that is very volatile, I'll give an example. Your methylated spirits. If methylated spirit pours on the table, it changes quickly. It dries up. Your Q-Tex, that's why you always close it all the time. It's very volatile. It converts quickly. That is volatility. Guys, I am done. I hope I've been able to assist everyone with organic reactions. And that's just it. Take this and apply. You get full marks. If there are questions, okay, what this is making noise. If there are questions that you feel might be challenging, please ask, send it through, and let's deal with it together. Next week we might, okay, this is annoying me now. What we will do in our next session is to consolidate. I know you might be done with exams, but all good. We'll just consolidate everything on organic chemistry in one lesson, and we answer questions, question 2, 3, 4, and I'll also be looking at empirical formulas on this particular concept. But all well and good. I'm happy with what I did, and I hope you are happy too. Good night, everybody, in the absence of no question. Bye-bye.